Hi, everybody. Welcome back to Environmental Science Analysis with Dr. Lisa. Today, my video is going to be about the essence of coding, like the first video you should ever watch about coding or programming, whatever you want to call it. And this video is what I wish someone had told me when I first started to code for the first time. How do I even begin? Why am I looking at this funky blue screen? So what I'm looking at is RStudio, which is the interface that you use to do coding in the R programming language. But what I'm going to tell you applies to any modern programming language, okay? So don't worry, it doesn't have to be R. The essence of coding, again, what I wish someone had told me is that there's really three simple steps. First, you create an object, right? An object. This object is often what we would call a data frame. A data frame you can think of as just a table with two-dimensional table, a table of data. But it could be a list, it could be other things, but it's an object. You create an object, you put some data into it. Again, could be a table of data, could just be a list, and then you do something to it. This is all there is to it. It's not that complicated, right? So here's an example. I'm going to create this thing, I'm going to call it my data, because that's a really good name. I could call it Fred. I could call it Beyonce. It doesn't matter. I'm going to call it my data, and I'm going to put something into it by reading it from a CSV file, and I'm too lazy to type in the long path. So I'm just going to choose this. I'm going to use this file choose thing, which is going to pop up this little box. And I'm going to go up here and find my data, which is probably a little harder than it should be. I keep it in a folder called RCode, and I created something called test data. Notice that the name of the file was test data, but the name of the thing that I just created is my data. It doesn't have to be the same. All right, so I created it, and lo and behold, it's popped up. It exists over here now. And I could double click on it, and there it is. And it's just some numbers. I called them X and Y for reasons that will become obvious in a moment. So it's just some numbers. I imported some numbers. I created an object that I called my data. I put some data into it, and now I'm going to do something to it. Let's say I wanted to do a linear regression. Then I would use LM, which stands for linear model. If I'm not sure, I could go over here to the help menu and type LM, and it would come up with LM, and it would tell me that it's in the stats package and that it fits linear models, and that it would explain to me how to do it. But this is a very simple one. So you run this function called LM. You tell it very explicitly where to find the data it's going to use to run this function. And then in this particular example, you give it an equation. So I'm saying regress y as a function of x. So y equals x. The tilde here is acting as like an equal sign, sort of. So now I could run that. Okay, so let's say I just run this. Let's say I don't give it a name or anything. I just run it. Oops. I could run it, and it gives me intercept and a slope, just like any other linear regression. But right now, this doesn't exist anywhere except on my screen. Remember, when in doubt, repeat steps 1 through 3. So what I could do here is create a new object. This is where the naming of your objects starts to become important. I could call this Dr. Lisa the Stallion, and then use the little arrow to feed into it, right? But that's not a very good name. First of all, it's quite long. And second of all, it doesn't tell me anything about what's inside that object. So instead, why don't I call it my data, and then I'll call it .lm. So now I know that this is the output of the linear model used and run on my data. So I've given it a name that actually makes some sense. Note that your names can't have any spaces, which is why I put the dot there. Now I could run this and look over here. When I hit enter, control enter, and voila, now this exists. When I click on it, it's kind of ugly, but it's all there. The coefficients, the residuals, the rank, the fitted values, all this stuff. It's all there. It exists now. It's an object. And now I can do things to this object. And so what happens as you're programming is you start accumulating lots and lots and lots of data sets over here, lots of data frames and lists and other things. But that's the essence of coding. You create an object, you put something in it, and then you manipulate that object. You do something to it, okay? Very, very simple. And if you want to sound really fancy and impress your friends, you can tell them that the way you're doing this, the reason you're doing this is because you are working with an object-oriented language. Most new, modern programming languages are object-oriented, which is why we do this. We create an object, we put something in it, and we start to manipulate it. All right, that's the number one lesson. Number two lesson is syntax. This is a fancy word, and it's not a word that we use very often. And so it might seem a little, like, what is syntax? You kind of know, you think you sort of know. But syntax describes how you put words together and give them meaning. And so for those of us who are not used to the word syntax, maybe it's better to use the word grammar, and that might be something that makes a little bit more sense to you. And for me, I learned how to diagram a sentence back in, I think it was 8th grade. That sounds something about right. And so if you use a sentence like this one, the quick brown fox jumped over the lazy dogs. This is a very famous sentence in English because it uses all 26 of the letters of the alphabet. So when you're testing your keyboard to make sure it works properly, you might want to type this sentence. And in 8th grade or somewhere around there, I think most of us would have learned how to diagram this sentence. Remember that? And diagramming the sentence starts with what is the subject and what is the verb? Okay, in this case, fox is the subject of the sentence. It's the thing that's doing something. And then jumped is the verb. And I will flash very quickly on the screen, not because you care, but because I want to show that I did go to the trouble of Googling this. This is what the diagram looks like of the sentence. There you have your subject, there you have your verb, and all these other words are just modifiers that explain that the fox was quick and brown, and that he jumped over something. He jumped over a dog, and the dog is lazy. Lazy modifies dog, quick and brown modify fox, over modifies jumped. So I'm sure you don't remember that, and it's fine that you don't remember that. But the point is, when you are learning to code and you're trying to figure out how to do something, very likely what you're going to do is you're going to Google it. And you're going to go find something from Stack Overflow or something like that. And I just was doing that. I was also turning off my music. So that's that. But here's where I was Googling how to do random forest. So this is an introduction to random forest in R. And I looked through here, and there's a lot of stuff in here, and I had to kind of wade through it. But when I start drilling down, what I find is that the really useful part is right here. Now that we have installed the random forest library, let's build the random forest model. Aha, this is what I'm actually looking for. Here's the line of code that runs my random forest model. So I'm going to copy that, and I'm going to paste that into R. Boom. And notice, so this is where you get into syntax, i.e. grammar. The hard part of programming in R, at least for me, is looking at this line of code and saying, what the hell is this? What is this? So the way to think about that is to think about it like it's a sentence and ask yourself, what's the subject and what's the verb? And the syntax of R, and maybe this is true of some languages, maybe not others, but in R, the verb is almost always this first thing right before the parentheses. So the verb here is random forest. That's the thing you're going to do. That's the action. You're going to run this model called random forest. And then right after it is, in the parentheses are basically the rest of the sentence. You can think of this as the rest of the sentence. And R is often quite explicit for you in telling you what the subject of the sentence is. The subject of the sentence is train. You've told it, data equals train. Ah, okay, now I know where this model is getting its data from. I better make sure I have something over here called train, or when I try to execute this model, it's going to say, I can't find it, could not find, well, first of all, it says it can't find the function random forest because we haven't loaded that up yet. But it would also come back and say, where's train? So if you wanted to run this, you need to recognize that the object of the sentence, the data, is train, and you don't have a thing called train, so you need to change this to my data. And notice how it will even pop up some helpful stuff here. And then the other thing you have to recognize is that this thing that says n tree equals 1,000 and m tree equals 5, those are modifiers. They're sort of like adjectives. They're telling it exactly how to do. You can think of them as adverbs, because they're telling you how to run the random forest. Run the random forest with n tree is number of trees and m try is the number of tries. So try it 5 times using 1,000 trees. But the point is, those are modifiers. So you can pick this apart by understanding the syntax. And again, it's always good to start with what's the subject and what's the verb. And just for completeness, I will tell you that just like up here where we did y as a function of x, here we're doing taste as a function of, and then this little dot is doing a lot of work. This little dot is saying regress taste against everything else. That dot means everything else in the data frame. Except in this case, minus quality, which is saying except not quality. But that's what this is doing. And the point is that once you start to understand the syntax, you can pick this apart and understand it. And so that when I try to run this, and if I still had train here and it didn't work, I wouldn't say, what happened? I would go, oh, I forgot. That's the subject of the sentence. It better be over here. It better exist. And if it doesn't, I need to change the name of it. And maybe next time I run this, I won't run it on my data. I'll run it on someone else's data. I'll run it on Lisa the Stallion's data. So the point is, again, syntax, i.e. grammar. Look at the sentence, pick out the subject, the verb, the modifiers, and figure out what is what, and then you can start to substitute. Okay, the subject of the sentence is no longer train, it's my data. The verb might change. Maybe the verb right now is random forest, but in the next line, it'll be something else. So figure out the subject, the verb, the modifiers, and that will help you to pick apart this code that you find on the internet and adapt it for the purpose that you want to use it for. So that is the essence of coding in any object-oriented programming language. You're welcome. I wish someone had explained that to me a while ago, but now you get to profit from my ignorance. Bye.